You're able to see, right?
Yes, sir.
Okay. So we did a problem.
Sir?
Yeah, tell me.
Yes, sir. Yesterday I was writing the exams. I didn't
No,
finish it, sir.
Mithun, we'll talk about that later. Okay. Not here.
Okay, sir.
I'll message you guys.
Yes, sir. Okay, sir.
Okay. So I told you what were the assumptions that are done in strings. One is the string should be inelastic and the string should be massless. Right? When these two parameters are satisfied, then what will happen to the tension at both the ends of the string? So if one end of the string, if the tension is in upward direction, the other end it will be in the downward direction. So this we saw, right? Similarly, if it is a horizontal case, in one direction if it is to the right, the other direction it will be to the left. Now, so we did a problem which is based on it. Now I'm giving you another problem. So let's say there are three blocks, M1, M2 and M3, which are connected with the help of a string. Let's say I'm applying a force F to pull the whole system. Is this clear? Now my work is to find the acceleration of each block. So your answer should be in terms of F, M1, M2 and M3. So that is what we need to do. So how to proceed? Let's see. So if I take M1 here, if I apply a pulling force F here, there is a string like this. Okay. Now tell me if the acceleration on this block is A1, let's say. Okay, if I'm saying the acceleration on this block is A1, then how will you draw the free body diagram of it? So I've drawn F like this. Now, what will be the direction of tension at this point? I'm marking it with red color. So what will be the tension at this point? So when you're trying to pull it, what is experienced by the string? Is the string experiencing a pulling force or a pushing force? You're trying to pull the block M1, right? Then M1, will it try to pull the string or push the string?
Pull the string, sir.
Pull the string, sir.
Yes, it will pull the string. Because this particle, the red color particle which I marked, will also tend to move in the leftward direction. So if the object is moving in the direction of pulling force, means the object is being pulled. So the tension is experiencing a pulling force at which point? At the point where I marked with red. So what will the string try to do? Will the string have a force in the rightward direction or leftward direction at this point?
Rightward.
It will have in the rightward direction. If we call this tension as T1, then this is going to be the free body diagram of whom? Of M1 in such a way that what is the relation between Ft1 and A1? F minus T1. Why did I F minus T1?
Because they are in the opposite direction.
Opposite direction.
So they are in the opposite direction. So I'm applying the same formula. Sigma F external is equal to mass into acceleration. So mass of the object is M1 into acceleration of the block is A1. So I will call this as equation number 1. Is there any doubt till here? Is it clear? So this is the free body diagram of whom? First block. Now, what is the free body diagram of the second block? So if I name this as string 1 and if I call this as string number 2, the string 1 is attached to how many blocks? M1 and M2. right? On M1, if the tension force is acting to the right, on M2, the same tension force at the other end will act in leftward direction. And what is the reason for it? The obvious reason for it is the whole system is moving to the left. Correct? So
Yes,
if the
sir.
whole system has to move to the left, yes, on M1, we are applying an external force. But what external force on M2 is responsible for its motion? That is, M2 has connection. Does M2 have connection to my hand, or is it having connection only to the string?
The string.
So the string force is what is responsible for this M2 to move. So when this M2 is moving to the left, then the tension that is acting here is T1. Accepted? Because it is the same string. This is string 1. This the same string 1. So on string 1, if the tension is T1, here also the tension is T1. I hope it is clear. But M2 on the other side is connected to M3 also with the help of another string. But my concern is only about how M2 is connected to the string, because it is an intermediate medium. Now what will happen to the force on the second string? On the second string, what will happen? Is the second string being pulled or pushed?
It's being pulled, sir.
It is being pulled, means the tension on the second block, a second string, will act in the rightward direction or leftward. When something is being
Word,
pulled,
sir.
sorry,
Right word.
it is rightward. So how much value will get added? It will be
T1 plus T2, sir.
T2. So this is A2. Right. So tell me the equation. T1 minus T2 is equal to M2 into A2. Is that clear? What will happen on M3? So M3 is connected to how many blocks? I mean, M3 is connected to M2 with the help of only one string. Is it right?
Yes, sir.
Yes, sir.
Okay. So this is string number what?
String number 3, sir.
It is 2 only.
Two only, sir. Sorry.
There are 2 strings, no? So on string number 2, what happened on the right of it? I mean, what happened on the right of M2? T2 was acting to the right. What will happen on the left of M3? The same T2 will act to the left, because tension is an action reaction pair. If this is A3, then T2 will be equal to M3 into A3. Let this be equation number 3. So T2 will be equal to M3 into A3. Let this be equation number 3. I hope it is clear. Okay. Is there any doubt in any of the free body diagrams?
No, sir.
No, sir.
Okay. But there is one mistake in the equations I've written. In all the 3 equations, there is one mistake. Let me see if you guys can correct it. Okay, can even guess, not an issue. So F minus T1, there is no mistake. T1 minus T2, that side there is no mistake. T2, there is no mistake in the third equation. But there is a mistake on the right side of every equation. The important point to be noted is when the
Let us
string is,
specify direction, sir.
no, it is the same. Direction is right. Everything is right. One important, the reason I wrote it, because you will remember what mistake you're not supposed to do. Okay. The reason, whenever you see the word, the string is inextensible. I'm repeating it. Whenever you say the string is inextensible, then all the objects which are connected across the strings will have the same acceleration. Please make a note of it. This can be proved, but it is beyond your scope. So I don't want to confuse you because we have to use differentiation to prove it. I'm repeating the statement, make a note of it. Wherever you see that the string is what? Inextensible. Wherever the string is inextensible, the acceleration of all the blocks present in the system will be the same. I hope you guys made a note of it.
Sir, your voice was a little breaking, sir. Can I say again, sir?
I'm saying when the string is inextensible, all the blocks connected together, will have the same acceleration. Done? So I'm going to solve all the three equations. F minus T1 will be equal to M1 into A. Okay? T1 minus T2 will be equal to M2 into A. And T2 will be equal to M3 into A. Okay? So in all the questions where tension is involved, if you add all the equations, generally tension gets cancelled. T2 and T2. So F will be equal to M1 plus M2 plus M3 into A. So what will the acceleration of the system be? So F divided by M1 plus M2 plus M3. Is that clear?
Yes, sir.
It's coffee, sir.
Right.
So what is T1, sir? T1 and T2, sir?
Tension 1 and tension 2.
Oh,
Sir, if acceleration is not same at each block, then what?
That's not
there'll
there
be-
in your syllabus. That's not there in your CBSE syllabus. That's
Okay,
there only for competitive part. You need not worry about it. Okay. So here, how many blocks were connected? How many blocks were there in the system?
3 blocks, sir.
3 blocks. Now, if I give you a question like this, M1, M2, so on, there are n blocks connected together, and I have applied a sufficient amount of pulling force to move all the objects. So all the objects will have the same acceleration because by default the string is inextensible. So every block will have the same acceleration. So what will be the answer direct? Can you tell me directly? Can you tell me in one step? A will be equal to F divided by
M1 plus M2
Dot,
plus
dot, Mn.
Mn.
That's right. Did you guys understand? So this is how it will work. But don't use it like a formula. There's a concept. Are you guys clear with this?
Yes, sir.
Yes. So this is what happens when the blocks are connected with the help of a string. Now what I'm going to do is, so these blocks, are they placed on the floor or not? So they are placed on the floor. So in addition to tension, they will also have
Wait, sir.
yeah, it will have weight also.
And normal force.
M1G will be there, M2G will be there. But what happens is the normal force and the weight are balanced. That is why in our acceleration equation, we never use them. Because acceleration is happening along which direction? X direction or Y direction?
X direction.
X direction.
But the normal and the weight are balanced in the
Y.
Y direction. That is why we don't involve them. Okay. Had there been acceleration to the object in the Y direction also, we would have involved them. Now the next set of questions that you can get are when there is a pulley, you know what is a pulley, right? These wells and all will have, when there is a pulley over which there is a string that is going, and there are two blocks which are connected on either side, M1 and M2. See guys, I am reminding again, this chapter and next chapter, you have to practice a lot of problems because these two are the basic for physics. For almost all the chapters that you learn, every concept of vectors and everything gets applied here. So you need to practice a lot of problems. Okay. Suppose M1 is greater than M2, what would have happened?
M2 would rise up and M1 would go down.
M1 will go down and M2 will rise up. Okay. So for any object to accelerate, what is necessary? For any object to accelerate, I'm putting a question like this. What is necessary? You need unbalanced forces. Unbalanced forces make an object accelerate. Okay. So if you observe M1 and M2, they are connected with the help of one string or two strings.
One string, sir.
One
They are
string.
connected with the help of one string. Okay. Now, if I draw a free body diagram of M1 alone, then M1G will act in the downward direction. There is a string that is connected here. Okay. There is a string that is connected here. When you place it here, is the string getting pulled or is it getting pushed?
It's getting pulled, sir.
It is again getting pulled only. So the string will try to exert a tension force in the upward direction or downward direction.
Upward direction.
Okay, let me call it as T1. Similarly, if I draw a free body diagram of M2, what will happen? It will be M2G. M2G is also trying to pull the string. So here what will happen? The tension will be in upward direction or downward direction.
Upward, sir.
So here also
Downward.
it will be upward only. T2. It will be upward only because see M2G is pulling. See, look at this particle. This particle has a tendency to move downwards. So tension should stop that particle from moving. It will try to make an attempt to stop it to make from making it move. Okay, so it has to act in the upward direction. There is a mistake in my diagram, correct it. Not with the directions. Directions are perfect. One physical quantity, I wrote it wrong.
The tension is T1.
Tension
Tension is the same in both. And the reason for it is they are connected with the help of
same string.
Yes. So the number of strings that are there in the diagram is equal to the number of tensions that should be in your equations. For example, here, how many strings did we have? 2 strings. That is why we had two tensions, T1 and T2. If there is only one string, it will be only one. So I hope it is clear. It is m2 into g. So here the acceleration is upwards, here the acceleration is downwards. Okay. So how to write the equation for the first one? So how to write the equation for the first block? T so which direction is the
Equal
object?
to M1.
Minus M1G.
So sum of all the unbalanced forces is equal to mass of the object into its axis,
1A.
m1a. Similarly, for the second equation, it will be m2g minus t is equal to m2a. Right? m2g minus t is equal to m2 into a. So if I add both, t and t will get cancelled. Then m2 minus m1 into g is equal to m1 plus m2 into a, which implies a is equal to m2 minus m1 into g divided by m1 plus m2. So this is the acceleration of both the blocks put together. m2 minus m1 into g divided by m1 plus m2. m2 minus m1. Guys, are you clear with this?
Yes.
Okay, now what I'm going to do is I'll give you another diagram. See. So there is a pulley across which there is a string that is connected. This M3. Okay, so they are connected like this. We need to find the acceleration of system. Though I'm saying M2 plus M3 is greater than M1. Means this will move in the downward direction, this will move in the upward direction. They both have the same acceleration A. Our work is to find the acceleration of both. So how to do? How many blocks are there?
3, sir.
So 3 blocks, 3 free body diagrams. How many strings are there?
Two
Two
strings.
2 strings, 2 tensions. Okay. So let's start with M1. For M1, what is going to happen?
Sir, is the acceleration correct? The direction of the acceleration.
Yeah, it is right.
Then for the before diagram, you put the same direction.
Wrong. Oh.
Oh, for the previous one I changed to. Okay, I'm
Yes,
sorry.
sir.
Then I'll change the question here. I'll change. Sorry, that was unintentional. So it is M2 greater than M1. Okay, so you can make a change of this part up. Okay, now see, M1G is in the downward direction. In upward direction, what will act? String, it is tension. So
T1.
T1. Okay, so this will be acceleration in the upward direction, which implies T1 minus M1G will be equal to M1 into. Can I say this?
Yes, sir.
Yes, sir.
T1 minus M1G is equal to M1 into A. Now, what will happen to M2? So, when you're drawing a free body diagram, you have to see what is there on either side of the block. For the upper part of M2, there is a string. For lower part also, there is a string. So, upper part, what will happen? So, M2 is moving in downward direction. Who's pulling M2 down? Sorry?
The gravity, sir.
It is a string.
String, sir.
It is T2. String is trying to pull it in the downward direction. Along with that, there is a weight of the object also acting, that is M2G.
And
Then what
T1
will-
is pulling out.
Very good. And T1 is trying to pull up. So what will happen here? In which direction is it moving downward? So in which direction the forces should be greater?
Downward.
So what are they? M2G plus T2 with minus T1 should be equal to M1 into A. Accepted. So this is equation number 2. Whereas what is happening with respect to
So it's M2A only, sir.
M2A. So M3, what will happen is M3G, and what will happen in the what will act in the upward
T2.
direction? It is T2, and acceleration is in the downward direction, which implies M3G minus T2 is equal to M3 into A. Okay, so what are we supposed to do? Add all the equations. That is the only way to solve. So first equation is T1 minus M1G is equal to M1 into A. The second one is M2G plus T2 minus T1 is equal to M2 into A. Third one is M3G minus T2 is equal to M3 into A. When you add everything, T1 gone, T2 and T2 are gone. So what will you get? M2 plus M3 minus M1 into G is equal to M1 plus M2 plus M3 into A. So A will be equal to M2 plus M3 minus M1 divided by M1 plus M2 plus M3.
Sir, for n number of blocks,
For n number of blocks?
is it possible to
Yes,
find
it is.
fully?
Yeah, it is. It is possible. So if I say that the acceleration is taking place in this direction, then how to write the answer in one step is A is equal to sum of all the greater masses m2 plus m3 plus m4 plus so on till mn minus m1, and the numerator should be multiplied with g, the whole divided by sum of all the masses. Okay, but again, there is not a formula. There is only for you to verify whether the answer you have got is right or not. Is that clear?
Yes.
So this is all about fully based problems on level surface and on horizontal and vertical. Now, one more type of problem that can be asked are okay. So let me take this angle to be theta. Now, what is going to be the acceleration of this system? Okay. So one thing I asked you to remember, whenever you have an inclined surface, what is the force that is acting along the surface? You can recollect it. What is the force on the block on an inclined surface along the horizontal?
Sine theta.
It is m1g sine theta. Okay. Now see, if I draw a free body diagram of m1, then this side it will be m1g sine theta, and this side it will be tension, because on the other side it is connected to string. Okay, tension is always a pulling force. Have this in your mind, right? So this is the acceleration. So which force is greater than other?
M1g sine theta.
So m1g sine theta minus
T
is equal to,
M1a.
that's it. Let this be equation number 1. Similarly, when you draw for m2, what is happening? There will be m2g sine theta accepted. Similarly, this block is also connected to a string, so it has tension, because the same string, no, this one and this one are connected at the same string. So on the same string, if one direction is upward, the other side it should be downward. Acceleration is still a. Now tell me the equation. m2g sine theta
Plus P.
plus t equal to m2 into a. This will be equation number 2. So what will be the equation? m1g sine theta minus t is equal to m1a. m2g sine theta plus t is equal to m2 into a. When I add both, they both get cancelled. And m1 plus m2 into g sine theta will be equal to m1 plus m2 into a. So acceleration will be Is it clear? So do you remember this g sine theta? You got it when you had only one block also. Here you are getting the same g sine theta when you have two blocks which are connected with the help of a string also. Similarly, let's say there are n blocks connected like this along the inclined plane, along one side of the inclined plane. Then what would be the acceleration?
G sin theta.
It is still g sine theta because it is independent of the number of mass you have in the system. Are you guys able to understand this? Okay. Next is the last set is like this. The blocks will be on either side of the inclined plane. And they are connected with the help of a pulley. I hope it's clear. Now I'm saying that the object is, the whole system is accelerating like this. Now I want you to tell me what is the answer A. I'm giving you 3 minutes time. Solve it. Time is 5:41. By 5:44, I want an answer. So if you can try it. 1 more minute. Yeah. Who got the answer?
I got something, sir, but I'm not
Tell
sure.
me.
I got m1 g sin theta 1 plus m2 g sin theta 2 equal to m1 plus m2 into a.
Is equal to M.
2g, sir. m2g sin theta 2.
What's wrong? Because you made a mistake with the sign. Okay. So for M1, what is the free body diagram? It is M1G sin theta 1, and here it is T. Similarly, for M2, it will be m2g sine theta 2, and this direction will be t.
Sir, why M2G, sir?
Why m2g na m2g only, no? For second block.
Sir, MG cos theta only should come, no, sir.
Right. Then what was I doing here? m2g sine theta. I told you along the inclined plane it will be sine theta. Perpendicular to the inclined plane it will be cos theta. You have to have this in mind because you will be using this at many derivations.
Okay, sir.
Oh, sorry. Tell me. T minus m1g sine theta 1 will be equal to m1 into a. Correct? Similarly, m2g sine theta 2 minus t will be equal to m2 into a. So when you add both, what should happen? T and t will get cancelled. M2 minus, m2g sine theta 2 minus m1g sine theta 1 is equal to m1 plus m2 into a. So what will be the value of a? It will be m2g sine theta 2 minus m1g sine theta 1, the whole divided by m1 plus. Rohan, you got your mistake. It is not
Sir,
plus.
I added.
Yes. Okay. So these are all the types of problems that they will ask you in the case of
Sir,
block.
this is applicable when M2 block is greater than M1 block, no, sir?
Yeah, it is. That's the reason. It is not because M2 block is having greater mass. It is because M2g sine theta 2 is greater than M1g sine theta 1. Because here it doesn't depend only on M2 and M1. It depends on theta also. In other cases, if you see, we don't use theta. Whereas here, it is dependent on what all? It is dependent on mass of the object and the angle of inclination also. Okay, so if they give you an option like M2 is greater than M1 in this case, you cannot say it is wrong because you cannot conclude from it. Rather, what should be greater than the other? M2 sine theta 2 should be greater than M1 sine theta 1. Then this is right. Okay.
Okay, sir.
So these are all the problems based on this, guys. Okay. So just a minute.
Sir, what is the next topic?
Yeah, just a minute. I'm checking. So the next topic is, write it down, law of conservation of linear moment. Law of, this is also a very, very important law. Law of conservation of linear momentum. Okay. So the question is, how is linear momentum related to force? According to Newton's second law, F external is equal to delta P divided by delta T. According to whom? According to
Newton's second law.
According to Newton's second law. Now, when I use the word conservation, conservation means it is preserved. Means nothing is lost. So what is conserved in this case? Linear momentum. Means what is the meaning of this is, whatever is the initial momentum of the system, the same is the final momentum of the system also. Okay. So delta P is nothing but final minus initial divided by time this F external. Now tell me guys, if P final, that is a linear momentum final, is equal to the linear momentum initial, what will happen to the external force? If P final is equal to Pi, mathematically what should happen to the external force?
Should become 0.
Zero.
It becomes 0, no force,
Yes.
external force.
So that is the meaning of conservation of linear momentum. So when I say F external is 0, it is nothing but Newton's third law. Correct?
Yes.
That's what Newton's law states,
Yes, sir.
right? Every action has an equal and opposite reaction. So what I'm trying to conclude is, if the net external force on a system is 0, repeating it, the next net external force on a system is 0, then the linear momentum of the system is said to be conserved. Okay, if the next net external force on a system is 0, then the linear momentum of the system is said to be conserved. So mathematically you can write it like this. Let us say you have two objects m1 and m2 which are having initial velocity u1 and u2. Okay, let's say they are getting collided. After collision, what will happen is, again they are moving in the same direction, let's say with velocity v1, and the second one is moving with a velocity v2. If you guys remember, in your 9th standard there would have been a derivation also based on this, right? Then mathematically it is written like this: m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, provided what? If external is 0. Is that clear? So what is this m1 u1 plus m2 u2? This is the initial momentum of the system. Similarly, m1 v1 plus m2 v2 is the
Final
momentum
of the system. Okay, it is not of the particle, it is of the system, because it's how many particle systems? How many particles? It's a 2-particle system. M1 and M2 are 2 particles, so it's a 2-particle system. Is that clear? So this is also a very, very important concept. You need to understand all these basics for you to understand the remaining parts of derivations.
Can I go a little bit up, sir? About this, sir. Yes, sir. Thank you, sir.
Yeah.
Sir, we can take this as a formula now, sir. A is equal to m2g.
No, don't do it. Don't take it as a formula, solve it. See how many steps? It's 3 steps only, solve it. Because in CBSE, they will not accept this as formula and all. They want you to solve.
Yes, sir. Thank you, sir.
Yeah. So it's final momentum like this. So this is the concept base. So tomorrow we will start the class with problems based on conservation of linear momentum, and then we'll proceed to the next part of this chapter. So before that, any other doubt from today's class?
No, sir.
Okay.
Oh, sir.
Just a minute. Yeah. So you can leave.
Thank you, sir.
Thank you so
Thank
much.
you,
Sir.
sir. Thank you, sir.